Ugh, I feel like my phone is stalking me. How so? You know, my phone is just giving me ads that specifically targeted what I just texted or Googled. That's machine learning. Machine what now? Machine learning is an integral part of how we live. It is a big subset of artificial intelligence. You can see machine learning everywhere, from ads to cancer research. Wait, cancer research? Yeah, a lot of scientists are taking machine learning and other initiatives to work on ways to diagnose and treat cancer earlier and more efficiently than ever before. But how? Machine learning is the science of getting a computer to solve problems without being programmed. There are two types of machine learning, supervised and unsupervised. In supervised machine learning, you specify what you want your computer to learn about. You have an existing set of data called a training set that has input variables and output variables. You do not provide any of this data in unsupervised machine learning. Back to supervised machine learning. It's one of the most common types of machine learning that researchers use to determine how cancer develops and how treatment can impact people the best. Researchers use a neural network, but let's explain how neural networks work. To start, we need a training data set that includes the patient information and data of those who have been diagnosed with cancer. This data is used to train the system and the neural network. A neural network is composed of an input layer, one or more hidden layers, and an output layer. During the training stage, we need to feed the network the first input variables. The ultimate output variable would be whether the patient would have cancer develop with a 0 for no and 1 for yes. The data you input will then flow through the input and hidden layers, eventually reaching the output layer. As each input moves between layers, they are multiplied by random weights. The weights are the most important factor in the conversion. The output would be a number from 0 to 1. This number is almost guaranteed to be wrong, so this is where the learning comes in. This is done through a process called backpropagation, which compares the output produced with the input it was meant to produce. Using the difference between them, an algorithm would modify the weights previously enforced, then run the program over and over again. Each time it is run, it gets closer and closer to the correct answer. After the intended output coincides, training is complete and you can test the network. Using our example, you can see whether the patient has developed cancer or how likely they are to develop cancer. Machine learning algorithms like these have higher accuracy rates than regular humans do. I am excited about the tech advances in machine learning to help in complex problems such as cancer research.